Hi there, we've been given another problem which is to find the Laplace transform of the function f of t equals sine 2t. We'll start with writing the very basic formula for this question, which is the Laplace transform of a function is given as the integral from 0 to infinity e to the power minus st times r function, which is sine 2t in this case. This integral can be solved using by parts integration, and wherein this will be the first function and this will be the second. Let me take this entire thing as I. So we'll write I equals integration from 0 to infinity e to the power minus st times sine 2t. Again, this is the first function, this is the second. Now the formula for this type of integration goes like this. The integral equals first function into integration of second function minus integration of derivative of first function into the integration of the second. So the first function into integration of the second function minus integration of derivative of first function times the integration of the second. From 0 to infinity, and here are the limits, and again 0 to infinity. Solving further, we get minus 1 upon s sine 2t times e to the power minus st from the limits 0 to infinity minus, and again minus, going to give us plus 2 upon s integral 0 to infinity cos 2t times e to the power minus st dt. Now this integral again is an example of integration by parts. This will be the first function, this will be the second. Solving further, we'll get minus 1 upon s sine 2t times e to the power minus st within the limits 0 to infinity plus 2 over s first function into integration of the second function minus integration of derivative of first function times the integration of the second. Solving further, we get minus 1 upon s sine 2t times e to the power minus st. Now let me take this 2 upon s inside, multiply it with each term, plus minus 2 upon s square cos 2t times e to the power minus st. Minus and a minus will give me a plus, again there's a minus, so minus 4 over s square. Now after this what's left is, let me just write it rather, we'll be left with integral of sine 2t times e to the power minus st. Now this integral is the very thing that we started off with, and we've taken it as I here. So all the way along these steps there is an I which I had not written up till yet. So from this step on we have, wait, let me just write this within the limits in here, 0 to infinity. Alright, so now we're left with minus 1 upon f s sine 2t times e to the power minus st minus 2 upon s square cos 2t times e to the power minus st within the limits 0 to infinity minus 4 upon s square I. So I've written down this entire integral as I. Now we'll take this term to the other side. That will give us s square plus 4 over s square times I, and this is equal to minus 1 upon s sine 2t e to the power minus st minus 2 over s square cos 2t e to the power minus st within the limits 0 to infinity. Now what we'll do is we'll simply put the values of the limits at places of t, and that will give us minus 1 upon s sine infinity e to the power minus infinity minus 2 upon s square cos infinity e to the power minus infinity minus, and again a minus, so a plus 1 upon s sine 0 e to the power 0 minus, again a minus, so another plus 2 upon s square cos 0 e to the power 0. This step on, what we're left with is, yes, so I will be equal to, before that, if we take a moment to observe here, e to the power minus infinity tends to 0. Again, e to the power minus infinity tends to 0. Sine 0 is itself 0. So what we're left with is just this term, 2 over s square cos 0 e to the power 0, which is equal to 2 over s square. So we'll write down I equals s square upon s square plus 4 into 2 upon s square. This gives us I equals to 2 over s square plus 4. To summarize the answer, the Laplace transform of sine of 2t is given as 2 over s square plus 4. This is the answer. Hope I was able to make the concept clear. I've been as elaborate as I could have been. I hope you understood the concept, and thanks for watching.